Hello, my name is Czartoryski,
And I'm Luke Albinger.
and this is our Fisherman game, which is a modified version of the counting problem seen in homework 5. So let's start with the original problem. The best go on to play in a series of 7 games against their rivals from the east side, the Bankies. The goal is to win 4 games in total. We record the outcomes of the game with a W for a best win and an L for a best loss. For example, WWW would be a win, as well as WL, WL, WLW, and the other one. So how many possible outcomes are there for the series? Consider the fact that the best can win or lose a series, and explain how you arrived at your answer.
Our modified fisherman problem to that problem was Joe and Alice are out fishing. They'll be playing a game where the first one to get 5 fishes is treated to lunch by the other fisher. However, a new rule was added in which if someone gets the first 4 fishes, the game is automatically over and the person wins. Examples of the outcome include the following. How many possible outcomes of the fishing game are there? The differences between this and the original problem are instead of having to win 4 games, it's to get 5 fishes. And there's an exception to the rule where if the first 4 fishes are caught by the same person, the game is automatically over. So we have to assume the last game only is one possibility. Since 5 fish are required to win, once, for example, Joe hits 5 fish, the game is over. Therefore, the last fish caught must be caught by Joe. This same concept can be applied to Alice as well. Since the last fish caught is by the winner, for the sake of argument, we would use Alice. Therefore, in the case of a game where 6 fish are caught, since the last spot is a fish caught by Alice, there needs to be 4 fish caught by Alice placed in the 5 remaining spots.
All right, so let's go about solving this problem. So first, we're going to find the sum of all the possible combinations without the first 4 rule. Because the last possibility only has one option, as discussed above. To find the possible combinations, we must add all the choice possibilities together. This results in 4 choose 4, 5 choose 4, 6 choose 4, 7 choose 4, and 8 choose 4. We're placing the 4 fish in the 8 spots, or the 7 spots, or the 6 spots, or the 5 spots, or the 4 spots. We will then multiply that number by 2, since either Joe or Alex can win. And without multiplying by 2, we would only be getting the total probabilities of one person winning. All right, so once we do all the combinations and we sum them up and multiply them by 2, we solve our equation and get the answer of 252 possible combinations for either Joe or Alice winning.
So now let's visualize the first 4 rule. The combinations shown on the slide are possible without the first 4 rule, but with the first 4 rule, they are not possible. So we must subtract 1 from each choice. As we can see, J, 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 J is not possible because they already won the first 4 games. And J, 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 A, J is not possible because they also just won the first 4 games. And that applies to the following. So now we're going to solve the problem with the first 4 rule. The combinations, like we said, we must subtract 1 from each of the choices due to the first 4 rules. However, we do not subtract 1 from 4 choose 4 as it is still a valid combination under the first 4 rule. And again, we must multiply by 2 to account for the possibilities of both players winning. We solve out the equation and get an answer of 244 possible combinations.
All right, to recap. So first we assume that the last game was a J or a W. This is because in order to win, you need to have the last one be a J or a. So then we considered all combinations as in the slides above, where we were doing 4 choose 4, 5 choose 4, 6 choose 4, 7 choose 4, and 8 choose 4. We accounted for the first 4 rule by subtracting 1, as explained by Luke. And then we multiply it by 2 to account for either Joe or Alice winning, since there's a possibility of Joe getting all 5 fish or Alice getting all 5 fish.